Hello, and welcome back for chapter 2.7. It's over inequalities involving absolute value. So we're still looking at absolute value functions. It's just now, or equations, but now we're just looking at them in a way that with inequalities. So remember, with inequalities, we have an or situation and an and situation. So the or situations, because the two inequalities are connected by the word or, we graph their union. That is, we graph all points on either graph. So for instance, if we have the absolute value of x, x is exactly 7 units from 0 on the number line. So that means x can either equal a -7 or you can equal 7. So when we look at an inequality, if we say the absolute value of a is less than 5, the absolute a is less than 5 units from 0 on the number line. So it has to be a distance of less than 5 units. So either from a -5 to 5, it's strictly less than. So we have this open circle at -5 and 5. Okay. So that means if I have, here is the absolute value functions. And if we want it less than 5, that means we want it to be less than 5. So we want it to be everything between here and here at a -5 and 5. So when it's less than, it's going to be in between. Less than means it's going to be everything in between. Let's look at a greater than. So if the absolute value of y is greater than or equal to 4, it says y is greater than or equal to 4 units from 0 on the number line. So it's either further than a -4 this way or further than a +4 this way. So a greater than is an or. It's a greater than is two separate areas. So let's look at I've got the notation here from the book that I copied for you to use. So when it's less than, it's in between. So we have a less than is in between. And when it's greater than, we've got a union. Okay. Example 1 says, solve the following inequalities using the definition of absolute value. Graph the solution set in each case. And I'm going to use integral notation. So first we have to isolate the absolute value. So I'm going to add 3 to both sides. So you have the absolute value of x is less than a +2. So because it's less than, just like up here, it's going to be between the two values. So it's going to be between, x is going to be between -2 and 2. And it's a strictly less than, so it's no equal to here. So we've got an open parenthesis, an open parenthesis. Okay, letter B says absolute value of t plus 5 is greater than 8. So again, I'm going to isolate the absolute value first. So now we have the absolute value of t is greater than a +3. So it's a greater than, so it's going to be an or situation. So it's either less than the negative or greater than the positive. Less than the negative or greater than the positive. Okay, less than the negative. So t is either less than the negative of 3 or t is greater than the positive of 3. That's how that is. So that's a negative infinity up to a -3 parenthesis union a +3 to a positive infinity. So it's less than the negative or greater than the positive. So I did example 1A and 1B. And now we're gonna look at example 1C, D, and E. So C says the greater absolute value of y is greater than or equal to 3. So greater than means that we're on the outside. So it's either y is less than the negative of a negative 3, or it's greater than the positive of a negative 3. So y is either less than, opposite of a negative 3 is 3, or greater than a negative 3. So that seems weird because that would be everything, right? It's going to be less than 3. So if we look at it on number line, we've got a positive 3 open circle, but it's everything less than that. And then we've got greater than a negative 3. So at a negative 3, we've got an open circle and it's everything greater than that. So it's everything. So that's a negative infinity to a positive infinity. If you look at this on a number line or on a graph, the absolute value of y is just this basic graph here at 0, 0. It goes out like a V. And we want to know where is the absolute value greater than a negative 3? Well, y equal a negative 3 is down here. So that means everything, yes, everything is greater than a negative 3. So it is indeed all real numbers, a negative infinity to infinity. It didn't seem like that's possible. Let's look at D. D says the absolute value of x less than or equal to a negative 4. Now, in a contrast, let's look at this in a graph too. So we have our regular, when it's just the absolute value of y equal to x, it's just this v at the origin 0, 0. We want to know when is the absolute value of x less than a negative 4? Well, here's the line y equal to a negative 4. So the absolute value of x can never be less than a negative 4. So it's not available. There's no answer to that one. Now we have the absolute value of x less than 2. Okay, so that means x plus 4 is between a negative 2 and 2 because it's a less than. It's between them. So now I'm going to solve for x by subtracting 4 to all 3 pieces. So negative 4 is less than x is less than 2 subtracting 4 is a negative 2. So we have open at negative 6 and open at 2. F is on the extra video. G and I are on the extra video, and we're going to look at H. So we're going to isolate our absolute value by adding 4. So we have the absolute value of 6x minus 1 is less than or equal to 6. So when it's less than, it's in between. So negative 6 is less than or equal to the 6x minus 1 is less than or equal to the positive 6. And then we just isolate x. So we're going to add 1. So we have a negative 5 is less than or equal to 6x is less than or equal to 7. And then we're going to divide by 6. So we have a negative 5, 6x is less than or equal to x is less than or equal to 7, 6. And then our interval looks just like similar to this. So bracket, because it's a less than or equal to, there we go. And like I said, GI, and then J and K are on the extra video. And my last problem here for 2.7 is L. The absolute value of 2x minus 5 over 3 is greater than or equal to 1/6. So that means I am less than a negative 1/6 or greater than a positive 1/6. So 2x minus 5 over 3 is less than or equal to a negative, or 2x minus 5 over 3 is greater than or equal to a positive 1/6. So it's because it's greater than, it's less than or equal to the negative, or greater than or equal to the positive. So I'm going to first divide through by my 6 because it's a multiple of 3 and 6 to get rid of our fractions. So 3 goes into 6 2 times. So I have 2 times 2x minus 5 is less than or equal to a negative 1. And when 3 goes into 6 2 times. So then I have 2 times 2x minus 5 is greater than or equal to a positive 1. So let's go ahead and distribute the 2. So we have 4x minus 10 is less than or equal to a negative 1. I'm going to add 10. So we have 4x is less than or equal to 9. And divide by 4, we get x is less than or equal to 9/4. And that is 2.25 in decimal form. Then over here, when I distribute, I have 4x minus 10 is greater than or equal to a positive 1. So when we add 10, we get 4x is greater than or equal to 11. And divide by 4, we get x is greater than or equal to 11/4, which is 2.75. So we have a union here. So in interval form, we have x, so a negative infinity up to 9/4 with a bracket, union, because these are less than or equal to, greater than or equal to, we have a bracket again at 11/4 up to a positive infinity. And that is all. Let me know if you have any questions.